it's been pretty amazing to be kind of at the forefront, at the cutting edge, to see all the luminaries in the field, and you find out that these big names are just people with a lot of common interests that overlap with yours, and who will only be too happy to talk with you about them.
So welcome to my talk. It's called It's Dangerous to Go Alone, a game developer tutorial. So some sort of caveats up front. I've been doing C++ a long time, okay? At least 20 years professionally, right? Time before that too. But I am not a game developer, right? It's always been one of those things that has been just so intimidating to me to be like, I don't know where to start with this, okay? But recently I got an opportunity to be more involved with game developers, with Microsoft products and stuff that we're making, targeting game devs. So I thought this is a great opportunity. I can use this now to learn the things I've always been sort of afraid to learn. So I'm gonna take you on a journey, the journey that I've been on the past couple months. This is information for beginners, right? If you are a professional game developer, raise your hand. Okay, yeah. So like, you're gonna see things in here that are gonna make you go, oh, I don't know why he's doing it that way. It's because I'm a beginner, okay? This is information for most everybody else. I still wanna hear your opinions and thoughts on stuff though. Okay, I got a lot of stuff, so we're gonna get right to it. Okay, so first off, we had a lot of Microsoft talks this year. We got a couple more tomorrow. You can take the survey at the QR code there. We've already raffled off all the prizes, but we still value the feedback you give us on the survey. Please go do that for us. Okay. This talk is structured in a very different way than most of the talks that are going to be here at the conference. Okay, who all here had played like old video games that had like manuals you had to read? Okay, that's a lot. That's good. Okay, how many people have ever played newer games where you learn to do something, you go do a walkthrough, like you go find a walkthrough online or something? Okay, it's a mix of those two things. So we're going to jump into it. It's dangerous. You have a dream to become a game developer, the game developer. You're going to find some challenges on the way. You're gonna have tools to help you beat those challenges, defeat those challenges. We're gonna go through some of those. We'll do the slides quick too. So the object purpose of the talk, the thing that it's structured around. About 14 years ago, I wrote an implementation in C++ of the board game Go. All console-based output and input, right? And I thought, wow, this is so cool, I'm a game developer, right? And I structured it in a way, I was like, eventually I want to put something cool on the front of this for this interface. But then it hit me. I'm like, I don't know how to do that. And it sat there for 14 years. So I'm gonna take you on a journey going from what was on the left to what's on the right, okay? There are URLs for repos down there. Those are live. They've got commits and you can look at them and see how I did it and what the process has been for those things if you wanna go look at them. Okay, we're gonna start off with any good instruction manual is gonna tell you about the fiends, the enemies you're gonna be facing, okay? Each one of these is basically like an avatar that's representing some challenge you're gonna have. Count Lagula, okay? Poor performance of your game is one of the first things people are gonna notice, okay? If you're dropping frames, if your input's lagging, if you've got glitchy audio, they're gonna complain, right? And if you're just hammering their CPU and it's making heat and noise, they're gonna complain about that too, okay? So how we beat this is we use tools that are performant and fast and don't give us those problems, right? C++, right? Okay, next enemy, Laurel Wipe. Okay, if you're doing game development, that's a complex task, okay? You're gonna be doing experimentation, you're gonna try something on, it's not gonna work. You're gonna want a source control system from the beginning, okay? There are some particular challenges with source control and game development, okay? You're dealing with large binary files, assets, and things like this all the time, okay? Things like Git don't really do large binary files that well, okay? You're often working with people who are not programmers. They're designers. They're designing levels and characters and models and stuff. They're not used to operating in the way that we as developers work with Git. And like I said, you're gonna be experimenting. You're gonna be trying something that didn't work. Okay, roll that back. Okay, try this, that didn't work, roll it back. you're going to want to be able to use those source control tools to enable that process. Null. Null is the creative vampire. It's the guy who's telling you, you're not creative. You're a coder. You're an engineer. You think analytically. You don't know how to make 3D models. That's challenging. But what you need to know is that things like LLMs are actually lowering the barrier here. I felt this way, but then I was like, well, let me just ask Copilot what it thinks how I should go about making a model. And it told me. And guess what? It worked. And I was like, oh, it's that easy? Okay. I'll show you how to do some of that. And lastly here, practice makes perfect. The more you do this, the easier it's going to feel, the more confident you're going to feel in doing that work. Heisenbug. Okay, everybody knows what Heisenbug is. Heard the term at least, right? It's the bug that's there until you look at it, and then when you start looking at it, it goes away for some reason, right? This is a particular problem in game development because in your game, when you're debugging it, you're actually running usually optimized code. Okay, debugging optimized code is hard, but you don't want to run non-optimized code because now the bug may go away. Race conditions change. Now you can't see it, right? And every time you have to like switch between these things, that long build test cycle, because games are big, they take a while to compile, especially Unreal Engine games, gets really to be a real big pain in the butt. We have some stuff to show you about that too. Okay, jumping onto tools. Try to get through this rapidly. This is not an exhaustive list. This is just a sampling. There's way more out here, but we're gonna look at some. So developer environments like Visual Studio, Writer, and Unreal Engine Editor. Okay, I'm gonna show you some Visual Studio and Unreal Engine Editor in my demos. Content creation tools like Blender and Maya and Audacity and Houdini, and there's tons of these things, right? Just pick one to get started with. We're gonna show you some stuff from Blender. It's nice because it's free, and the interface, I found it pretty simple. So we talked about source control a little bit earlier, okay? The name on here that you probably may not be familiar with is Perforce. Okay, Perforce is a source control system that is designed, they've designed their solution around the ability to do large files better than other solutions. Okay, so a lot of professional game developers will use Perforce or some mix of Perforce and Git, maybe Perforce for assets and Git for the source code. But if you really go down this path, you probably want to investigate Perforce as a solution for some of your stuff. We're not gonna do the things with that. We're just gonna do Git and GitHub stuff. More tools. There's always more tools, right? Libraries and SDKs. So if you're targeting certain platforms, there are gonna be SDKs that you're gonna be expected to use. Microsoft has some, PlayStation has some, Nintendo has some. Then there are also general purpose libraries that are doing things like computational analysis of stuff, linear algebra, physics engine type stuff, right? That's what Eigen is, a linear algebra, and Bullet Physics is like a physics engine. And lastly, the big one, the game engines. Okay, game engines are basically a big bundle, a big ball of wire of lots of different facilities and things that make your life way, way easier. If you have to basically do all that stuff yourself, you're gonna be working on your game a long time before it actually ships. Okay, several of them. Usually custom in-house engines are usually the most common ones, but there are off-the-shelf ones as well. Unreal Engine is one of the more popular off-the-shelf ones, and we're gonna be using some of that. Okay. Dig into some game engine a little bit more. So what does a game engine take care of? With some examples from Unreal Engine, okay? Input and output, controller, feedback in your controller, things like that, volume, sound stuff. Your game interface, how do you actually get bits on the screen and get them rendered and moving correctly, and collisions and things like that. Behavior and game AI. Whenever you talk about AI in the context of a game, you're not talking about AI like LLMs, right? You're talking about how do the non-player characters or other actors in your game interact with each other, usually dynamically, something called behavior trees and things like that. Plumbing, just normal stuff like, yep, you're gonna be allocating lots of memory in places. They have a lot of utilities to manage that stuff to make sure you don't make mistakes and slow your game down. game state and management, things saving your game, state of players if they're connected on the network or they have what's their ping, things like that. And then lastly, engines come with tools and other designers and things like that. These are usually applications that they use to make to create new levels or to help you with the build or things like that. Unreal Engine Editor is the big one here. Okay, so we're done with our manual. Now we get to start the actual walkthrough. Okay, so we're gonna start our game. Okay, so we're gonna press start to continue. That's me, by the way. I'm not wearing a hat in that picture, but okay. So let's start the game. Prologue, the Smith's Workshop. How do you get the right tools for success? Okay. Everybody play games that have prologues in them? Are they usually playable? Maybe, maybe not. It's an obligatory cutscene, right? You can't skip it. It's going to it. There is so much content that I planned for this talk that I can't get to all of it in the amount of time I have. So there are videos I've made. This is a link to a playlist on YouTube that's got the videos that are backing some of these talks. If you really want to see how to install Visual Studio, how to install Unreal Engine, how to install Blender, the easy ways, go up there, find it, and look at them later. This video for this one's about, I think it's like 7 or 8 minutes long. It's not very long. Some shortcuts that you'll want to know, like you can install a lot of things on the command line in Windows. Use winget. It's just like the package manager on Linux and Unixes. You can do it all from the command line. You can even tell it to be quiet so it doesn't bother you with UI or anything like that. You can install Git. You can install Blender that way. You can install Visual Studio that way too, but since we just released 2026, it doesn't have it in the winget repository yet, but it will eventually. The video actually shows you how to do it with the 2022 version, but it will work with 2026 as soon as that's available there. And then Unreal Engine, a little harder to install, but there are several ways you can install it. There's a link here to a GitHub repo. Professionals will actually fork this and put it in their project because they may need to edit the engine to do special things. If you're just beginning, don't worry about it. Just install it from Epic Games Launcher and you'll be good. Okay. So congratulations, we finished the prologue. We got achievements. We got the Apprentice Smith. We know installing tools isn't really that hard. We got the Aura Farmer achievement. We didn't have to do much. We just kind of watched and gathered the benefits of it. Okay, ready for chapter 1? Yeah. Chapter 1, the first battle, Creation's Edge. So laying the groundwork, getting projects created, making sure all the little pieces are working correctly. We got a cheat code. Yeah. Okay, anybody know what this cheat code is? Konami code. Okay, cheat code, Konami code. Congratulations, this is another video for this. Okay, I am going to show one thing here though. Okay, did that just switch back? Can I get out of that? Oh, that didn't do what I wanted it to do. Okay, now it's not in the right place. How do I get it to, is it extended? It is extended. Okay. Okay. I need to adjust the scaling on this. My bad. I'm sorry. I thought I was doing a duplicate, not extend. Display settings. Scale. Okay, that's a little better, right? But now I can't see it right here. I can see it right here then. Okay, so I've got an Unreal project loaded up that I created. You can see in the video. If you go to the video, you'll see how I actually got it created and loaded up in Visual Studio. I'm going to load up the Unreal Engine toolbar here. And of course, because my scaling is goofy, okay, there is this UE configuration page. Normally when you load up a project the first time, this will automatically pop up. You don't have to go find it. So the thing you need to know, this is the important part I want you to know about this part of the task, right? the way the Visual Studio's Unreal Engine integration works is that you generate the targets, which then show up in Visual Studio that you can then select. Okay, so you can see here, for instance, I have the Go target, which is my game, and I have the Go editor, which is the editor for the game. They're both targets within Visual Studio. Okay, and I have the development configuration. This is like a release configuration. It's got optimizations on, right? But not like fully, it's not shipping. This is a different configuration. If I wanted to add another configuration target to use in Visual Studio, I would just go select, let's say Go editor. Let's do debug game, Win64. I'll add that to my list. Then I gotta make sure it's selected here. And then you do generate. Generate targets. Okay? So that's gonna generate the targets, which will then show up in these drop-down lists up here. Okay? So if you first load up Visual Studio and you're like, I don't see the editor for my game, or like, this is the first place you go. You go look and see and make sure you generated those targets properly. Okay. So now I should see, so there's Go and Go editor, okay? And for Go editor, I should see debug game as well. That wasn't there before. I didn't show you that, but it wasn't there before. Okay. And then I need to go back to my slides. Oh, okay. Is that showing it? Nope. Well, I apologize. Okay. I'm going to just change this to extend, or to duplicate. That'll make it easier. Okay. All right. That won't be a problem again. Okay, another thing to call out here is that if you try to run the game inside Visual Studio and like you get a thing that says, hey, there's no content here, there's a thing you have to do. You have to cook the content to actually put it in the right place for the game to work. So if you launch the game from VS and it fails, look in the video. It shows you how to cook it. It's not hard, okay? And then you'll be able to run the game directly from VS. Okay, moving on because we got a lot of stuff. Chapter 1, the first battle, Creation's Edge, achievements unlocked. We finished it, everybody. We completed this one. Apprentice architect. You made some projects. You're getting a good start. Lord of Order. It's important that you'll see this in the video too. Whenever you start a new project, you usually start it from Unreal Engine Editor. Okay, but then you're going to want to get into your IDE pretty quickly. Okay, then from the IDE you run the editor again. Right? It's a target you run. Then from within the editor, you can then play the levels in the editor because it has its own sort of simulation environment there, okay? The cool thing is when you do that, it actually will debug, like it's connected to the debugger in Visual Studio, which is pretty cool. Okay, and we ain't got time for all sorts of stuff. This video was about 9 minutes, so we got the no clip novice achievement there too. Okay. Chapter 2, this is where things start to get a little bit more interesting. So now we've got this structure here, and we want to actually start putting stuff in the game. We want to make a level with a board, and we want to be able to put stones in particular spots on the board. Oh, another cheat code, though. Again, we got a whole lot of content, right? Anybody familiar with this cheat code? Doom. This is the Doom God Mode cheat code, okay? So this is the last one though. This is the last cheat that we're gonna have. Okay. I'm gonna show you real quick about making black and white stones though. And the good thing is I'm already on the right branch in my code. Okay. So we're gonna make stones to import into our game. Okay. In Go, the game is you're placing stones on the board and trying to capture by surrounding other people's stones. So stones are sort of like the main active piece that's moving around on the board. Okay, so let's make some stones. Okay, so this is Blender. I have it in light mode. It's usually easier, better projection in light mode, but it comes in dark mode too. And whenever you start Blender and it creates a sort of an empty default project, you just get this cube on the screen. Okay, we don't want a cube, we want a stone, right? We want a nice, flat, kind of round stone. Okay. There are lots of different ways to do this. I'm just going to select it and hit delete. That gets rid of it. So you might think, I don't know how to make a stone in the 3D modeling tool. Where do you even start with this? I'm going to show you. So you're going to go to add here. We're going to add a mesh. A mesh, think of a mesh as like, it's an object without sort of like all the stuff on it. There's no material, there's no texture on it. It's just like the wireframe of a thing, okay? We're going to make an icosphere, okay? I'm going to zoom in here with my scroll bar, or mouse scroll. So you see it's kind of tessellated or whatever, right? We're going to change subdivisions to 5. It's going to get a whole lot smoother. Okay, now it's starting to look like a sphere, right? More like a rock, I guess. Last step I'm going to do here to make it, I'm just going to change the scale factor. I'm going to change the Z scale, so the top to bottom. I'm going to change it to about 0.25. Boom. Guess what? It looks a lot like a thin, flat stone. Okay, was that hard? It was not hard. I always thought that this was like impossibly difficult for, like, I don't know where to start. It literally took 2 minutes. That's with me explaining it too. Okay, so now what we're going to do is we're going to export this. We're going to export it as a .fbx file. Where is my, there it is. Okay, we're just going to call it pebble.fbx. Export fbx. Okay, did it actually click it? It didn't. Okay, that's been exported now. Okay, so now we have this FBX file, whatever that is. So let's see if we can get it into Unreal Engine. Okay, so I'm going to go to my Visual Studio instance. Okay, if it will actually switch to it. Okay, there we go. I'm going to launch the development editor for GoEditor. Now remember, GoEditor is the tool you use to build the game Go, but it in itself is like an application, a game-like looking thing, right? It is the Unreal Engine editor with your Go project loaded into it. Sometimes this takes a while, especially the first time you run Unreal Editor. It can take a while because it has to compile shaders and other things like that. So you'll be sitting a while the first time. Okay, so in the video that I've already sort of hinted at, I already put a board in. There's some pretty cool stuff with the board. You should go to the video and watch that. Okay, so the board looks weird for some reason. Let me just play this. Okay, that resolved that. Okay. So first thing I need to do is I need to import. Oh, can everybody see this black fine? Do I need to change this to a light color? It's fine. Okay. So I'm going to pick my Pebble FBX. Okay, I'm just going to import that. I'm not going to pay attention to the details of those things because I'm trying to go quick. There were issues, but they're not going to be a real issue. And you'll see now we have this Pebble resource here. Okay, I'm just going to rename this. We're going to rename it. Let's do mesh stone. Let's do mesh black stone. I think I named it something else in the actual commits that I made in the repo, but I'll jump to another branch whenever I do that. Okay, so I made that mesh. I'm going to make a duplicate of it for the white one. Duplicate mesh white stone. Okay. Next thing I have to do for this is I have to create a material. Okay, so I'm going to add material. Okay. We're going to call this M black. Okay, and we're just going to go ahead and open that to edit it. Okay, so you can see this material is sort of applied to a generic object, right? I'm going to change a couple things about it. I'm going to change metallic to be 10. This just makes it shinier. I'm going to change the base color for this black one to almost pure black. Okay. So that's now the material that's going to get applied to the mesh. Okay, save, close that. I'm going to duplicate this, call it M white, and then I'm going to do the same sort of thing, but I'm going to change that base color back to like all white. The metallic's still going to be the same because I want it to be a little bit shiny. Okay, save that. Okay, now in the mesh, I need to open that up and I need to now apply that material to this mesh. So this is the black one. So I'm going to apply in black. Okay, that's good. Save that. Same thing for the white one. Apply M white. Okay, save. All right. Okay, last step here that we have to do is we have to actually create what's called a blueprint. A blueprint is like a bundle of sort of like asset type of things plus code and functions and other things like that. Okay, it's one of the fundamental parts of the Unreal Engine editor. You can build a game completely with blueprints. They have actors and other things like that. If you're trying to build a game that needs performance, though, you're going to have problems. Okay, that's why we use C++, and that's another part of the talk here later. Okay, so I'm going to do blueprint class, and I'm going to pick actor, and I'm going to call it BP black stone. Okay, I'm going to double click that to open it up. Now I need to add that mesh. Okay, so a static mesh as a component. Okay, I'm just going to leave it called static mesh. I'm going to save this and compile it. It does compile. It's an important step. Now what I can do is I can choose a mesh to put on it. To say this static mesh is this thing. So now you see we have our stone that's sort of the representation of that blueprint actor thing. Okay. I'm going to save that, compile it again. I'm going to do the same thing. I'm going to duplicate that. I'm going to go BP white stone. But of course, I don't want my white stone to be black, right? I want it to be white. So I'm going to come back here and I'm going to change that mesh to be mesh white stone. Apply that, save it. Okay, so that's good and everything. I'm going to show you one more small thing though, because you have to pay attention to these things. I'm going to take one of these blueprints and I'm going to drag it onto the screen, onto my board. Now this thing now lives in my level, right? It's a thing in my level that's there. But you see, it's kind of big. Okay, you have to adjust the scale of it in order for it to look right. So I'm going to come back in here, pick the static mesh, and I'm going to pick, what did I say I was going to resize it? 0.35. 0.35, 0.35, 0.35. Okay, let's save that. Okay, and you see, it got real small now. So now I can put a lot of these stones on the board and it's going to make a lot of sense. I'm not going to do it for the black one. It's the same process. You don't want to leave this on your board. I was just doing it to see what the size and how it looked and everything. Okay, everybody know how to make a stone now and get it into Unreal Engine? It's not so hard, right? Okay, moving on because we got lots of stuff. Okay, and project. All right, there's a lot more stuff in here. This video is about 10 minutes with some parts sped up because you don't want to watch it compile a lot. The end state of the video is the ability to actually click and place stones on the board. Okay, so you'll want to see what that looks like. You'll see it again when we get to the later demos too, but how to get there is in the video. Okay, we did it. We got past chapter 2. We beat that boss. The null, I would call this the null boss, right? Like, I don't know how to do this. Well, now you do. Blueprints are really not that scary. 3D modeling can actually be kind of fun, right? You get in there. They actually have tools where you can actually like scrape stuff off of the model, which is what I did the first time I did it. And it created like a really not symmetrical shape. It was pretty neat. You can pinch and move things around. And since we kind of cheated, we had a cheat code, we sequence breaker here, we got that achievement. Okay, 31 minutes. All right, now we get down to brass tacks on this, right? So like where did it go on? The whole point was that I have C++ code already that implements this game, and I want to use that in this, right? So let's see what that looks like. Okay, so I'm going to close the editor. Don't save those. And I'm going to switch my branches, once this is done unloading, to this one. Discard changes.
Michael, the slides are still projecting.
Oh, the slides are still projecting? Huh. Really? I am duplicating though. Did the duplication stop? Oh boy. Sorry, okay. Apparently it went back to extend mode for some reason. Weird. Okay. Thank you. I would have been real embarrassed if I'd kept on going. Okay. Okay, so I closed that out. I'm gonna switch to this other branch. Yeah, I discard the changes. It's all in the branch already, so. Okay, now the question is, did it actually do it? It looks like it did. Okay, of course I'm not connected to the internet. Let's hope, who thinks the internet's gonna work fine? Okay, we'll see. Okay, I want to use Copilot for this. Something went wrong. Can I tell it to reconnect? Apparently it is in a broken state.
Do you need to sign into the Wi-Fi?
I should, yeah, that may be it. Okay, I'm not gonna use Copilot then. All right. So basically what I need to do here, you can ask Copilot and it's gonna give you several different ways to integrate your C++ code into your Unreal code, okay? There's several different ways you can build it as a part of the build process for this. If it's CMake, there are some other kind of tricks you can use to get it in. The easiest way is to just lift the binaries and the headers from the build of the thing and just kind of like plop it down into a resource directory in the project. That's what we're gonna do, okay? In fact, I think I probably already have them in there. Yep, so there's this third-party directory. I've already taken the libs that I built from my Go CPP lib library project, and I've already copied them over using CMake install into the right place over in my Unreal project. Okay, that's something, the path of that we'll want to know. So how you do this by integrating these in. First thing you want to do is you're going to want to create a new module. Okay, so you right click on your project here, you do add Unreal Engine item, empty Unreal Engine module, we'll call this Go Impl. Add that. Okay, that all looks fine. Okay, so this is gonna now create this new module that's in the Unreal Engine project, and a module is gonna have basically its own like build instructions that are associated with it. Okay, it's got its like own target, own build things. Actually, it doesn't have a target, does it? It just has a build. Okay. All right, that looks pretty good. I'm going to cheat just a little bit though, okay? View all commits. I'm gonna look, can I actually look at that? Oh, it won't let me look at the other branch. Okay. So if I go to goimpl.build.cs, okay, autocomplete's gonna be a real pain if I don't have Copilot, isn't it? Okay, this is what I'm gonna do. I'm gonna fast forward again because I don't want to actually write this code live on stage. So, okay, so basically, you're going to change your goimpl build.cs to something like this. You basically have to tell it where are the public include files for what's the include path for your library. That's this public include paths.add. And you can see Copilot generated this code. It can nice step-by-step constructed the path and all those sorts of things. And then you actually want to tell it where is the static lib or shared dynamic lib if you're using those. Where is that at, right? It needs to know that stuff so it can expose that over to the Go module, the main module of the project. Okay. Once you have that there, you'll also want to make sure in the go.build.cs that you've added goimpl as one of the dependencies that it has. This is what actually then makes all of those header files and the ability to link to those things available in the goimpl. Okay? So Once you do that, you're going to be able to then build this just fine. You can actually then also include, like if I say in Go CPP, IntelliSense is probably going to get this messed up, but I could say something like include board.hpp, which is one of my header files from my library. I'm going to save. Like, yeah, I misspelled it. See, this is why I don't like typing live, right? IntelliSense is still may mess that up. But now if I do a build with Control B, it should build just fine. Switch to the build output. Okay. Sometimes building can take a while, right? Okay, you can see the build succeeded. So the actual compiler did not like throw up its hand to go, I don't know what board.hpp is, because it actually can see it, okay? All right, so that's the skinny on how you get an existing C++ library that you have built, a static library, integrated into your game, your Unreal Engine game. You can then use it like any other C++ code. You can write things that use that code, all the good stuff there. Okay. I think we're ready to move on to the next thing. Move to number 2. Okay. The second part of this part of the demo is I actually want to show that it is actually working. Okay. So I have a, over here in my Impl game controller, this is basically a mirror of the game controller that lives in the Go lib repo that does the console stuff. It kind of is doing the similar sort of stuff. There's a start method there. The start method has to basically take the players that you have, get them set up on the board, make sure their stone colors are set correctly, and then the state of the game underneath the internals is all ready to go. So I'm going to set a breakpoint here. I'm going to relaunch my Go editor. Now keep in mind that like this is code that is sort of like linked into Go. It's not Go editor code, right? Like I'm not starting the game in Go editor. But the way the Unreal Engine works is that you'll be able to hit this breakpoint when you run the level from within Unreal Editor. You'll hit this breakpoint like it's in the game. Okay, you can see the breakpoint just went live. Okay, so I can play this level by pressing play. And ta-da, the start function in my module got hit. Okay, so in theory, I should be able to like step into my library C++ code here, right? So I'm going to step in. That's still the module code. Okay, this is library code. This is actually a template. So maybe it's not technically a library code. Since it's a template, it's in the other thing. But you can see it stepped into function logger. But it also is like not exactly what you would expect. Because remember, this is an optimized build, right? So like your debugging experience is going to be a little wonky in an optimized build, right? But it's all working, right? You can see I'm actually running the library code, okay? And I'll show you real quick because this has the place stones ability. And I actually have a breakpoint here for that. I'm just going to keep going with that. Okay, so it placed a stone. You can see it's alternating placing white and black stones. Okay. Now, this the implementation I have for it right now is actually testing whether or not the move is valid. But it's not actually, the underlying game state doesn't know whether it's valid. It's just always valid. It doesn't know that you've placed a stone in the underlying game state. Okay. All right, but we're going to add that right now. So I'm going to close that again. Flip my little demo script over here. Okay. All right, so what I need to do, I need to go to my player, my imp player, okay? You know what, I'm gonna do the same thing I did before. I'm just gonna swap over to the other branch. Continue checkout. Discard changes. Okay, so this is what changed, okay? I added a place stone at function to my player wrapper. I have a wrapper around a player. This is exposed up to Unreal Engine. So in blueprints, I can create one of these players in the blueprint, right? And then he has a method that's exposed through blueprints called place stone at, okay? All that function does is just delegate it back down to the actual game engine, library that I have, right? So you can see it turns what Unreal Engine likes to think of, it likes to use int32s for these inputs and outputs for the blueprints. It's turning that into the coordinates that the library expects, and then it's getting the native player and it's placing the stone at those coordinates, and then it's putting in a nice little log that says, hey, yeah, you placed the stone here. Okay. Now, what this is doing is that it's actually registering inside the library that, hey, there is a stone at this position now. So now if somebody else tries to test to see if that position is valid for another stone, it will return false, right? Otherwise, it returns true. Okay, so I want to play this. I'm going to show you what it looks like to have that hooked up in the blueprints. Now, we haven't looked at blueprints yet, but they're pretty cool, okay? It really is a visual scripting language. You drag nodes off, and there's an execution path, and you can see how the data flows from one thing to another. The problem, though, is that sometimes code is complex. And these blueprints get really gross looking really quick, okay? The good thing is you can actually make functions for things, which helps clean things up a lot. But also a lot of times it's not developers necessarily writing the blueprints. A lot of times it's the designers of the game that are doing the blueprints with the expectation that a developer, a C++ developer, is going to come back later and optimize that and turn it into C++ code instead, okay? So we're going to look at blueprints. I think they're pretty cool, actually. It lowered the barrier of entry for me as a beginner. I wasn't as intimidated by it, right? I didn't have to learn certain APIs to use blueprints. It made it real easy. Okay, so where did it go? There, it's at the very bottom. Okay. So let's look at the BP grid marker. So whenever this game starts up, it dynamically inserts these grid markers across the board. And there's a variable that controls how many there are, so I can change that at compile time, basically. And then each one of those grid markers basically has a hitbox. So when you click the hitbox, it knows, oh, I need to do something here. I need to see if there's a stone here, if I can place a stone here, and if it can, then it will put one there, okay? So let's see what that looks like. Did I open it up? Did it not open up? Okay. So I opened up the blueprint, BP grid marker blueprint. So this here is the construction script. This is like a constructor for a blueprint, right? You're just kind of like setting some stuff, right? It takes a available hitbox as input. It sets the box extent for that thing, it sizes it so it works pretty well. But the important part here is this event graph. So the event graph is basically like, whenever this event happens, do these things, okay? I'm gonna zoom in here. So I have an event on when the hitbox for my marker is clicked, do a whole bunch of stuff, okay? First, it's getting the game state, and then it's getting some more information about the current player. It's getting information about my wrapper for the internal logic of the thing. It's then saying, hey, is the move that you're trying to make valid for this color? Okay. If it returns false, it's going to actually print out a string to the screen, or a string to the screen that says, hey, that was invalid. But if it's true, it's then going to like figure out, okay, what's the size of this stone? What should it be? Where should it get put? All those sorts of things, okay? It's then gonna say, okay, I know where to put the things, but I need to know which color stone to put, okay? So you're gonna switch on the current player, the color that they are. If the current player is the black player, you put down a black stone. If it's not, you put down a white stone. And this is where the logic that we just added, that place stone at function, comes into play. After we visually put the stone, you could do it before too, but after we visually put the stone on the board, we're then going to say, let's record inside our internal state that we put a stone there, okay? So we call this place stone at, okay? And we know, okay, the black player is the object that we're calling this function on. Okay, we're giving it the row and column to say, okay, this is the row and column that we're going to record internally that the stone is at. Then when that's all done and we've placed it visually and we've recorded it in the engine's logic, we flip the stone color so that now the current player is now the other color. Okay? So this way you can test to see, is it valid? I mean, was it a valid placement or not? Okay, a lot of information about blueprints. They're not as scary as they look. Okay, let's say I have lots of functions here that do some small things, some more complicated things. Okay, use the functions if you're doing blueprints. It'll also actually probably help your C++ developers too understand what they need to do. Like maybe they replace a function with a C++ function instead, right? Okay, I'm going to play this one more time, and I'm going to debug both the place stone at and also the, where is it? Is it valid? Is it not? It's not in this one. It's in the controller. Yeah, is move valid for. Okay, so I've set my breakpoints there. Okay, we're gonna play this. Okay, yep, there's my start function. I'm gonna F5 on that. All right, I'm gonna zoom in real close here, okay? All right, so I'm gonna place the stone, boop. All right, is move valid for? Gonna step over. You can see my locals here. Is valid is true, great, because there was no stone there, right? That's what I wanna know. I'm gonna send to my log, hey, yep, they tried to move here, it's valid. Okay, so now I'm gonna place that stone. So right now, right, this is being called from the blueprint, right? You see this blueprint here, right? This is the sort of internal funking and stuff that goes on for that blueprint to call the code inside, okay? The blueprint is actually in your call stack. Okay, so it's gonna place the stone, it's gonna record that it placed it. Okay, great. Now, let's see what happens if I try to place the white stone on that same spot. Okay, it might be a little hard because the stone might be covering up the hitbox some, but I think I can get it to trigger. Okay, I got it to trigger. I clicked just the right spot. I happen to know where the hitbox is. So, all right, so I'm gonna step through, but this time I'm gonna try to step into is valid move. It did not step into it. I pressed F11. I should have used probably the things up here, but it did not step into it. Okay, again, this is because I'm an optimized build, right? It can't do that. It can't step into it, okay? But if you notice, is valid is now false, okay? So that means that we properly, I'll highlight it here. So that means that we properly recorded that there is a stone in that place, so you can't place another stone there, okay? So we say that the logic there is working. Okay, I'm gonna continue that. And I'm actually gonna go ahead and stop this and move on to the next set of slides. We got 12 minutes. I think I'm doing okay. Okay, so showed you how to get your library that's been built already, integrated in with your Unreal Engine project. I showed you how to then, access it. And then I showed you how to use it. You can write a blueprint basically. So you add these macros to your C++ that exposes it up to the blueprints engine part of Unreal Engine. Okay, and that lets you then drag things on with blueprints and place those things. Okay, we did it. Chapter 3 is done. Things are starting to come together. We're placing stones. We know when to place stones, when not to place stones. There's lots of other stuff we're not going to get to, like capturing stones and things like that. I'll work on that later. We've got C++ in my Unreal, and you've got Unreal in my C++. Anybody familiar with that? It's like a Reese's peanut butter cup thing. You've got chocolate in my peanut butter. You've got peanut butter in my chocolate. Okay. And then let's go. We're masters, ceremonies, achievement as well. Okay. Last demo part. I kind of hinted at this in different parts, right? Effectively debugging your game. Okay. We didn't see it on that one, but there's a message that you'll get if you're running an optimized code called, when you look at your locals, a set of locals, the variable is optimized away. You'll either get that, or you'll get not defined, or you'll get junk, like stuff that's clearly not correct. Those are one of the three things you could see when you're trying to debug optimized code. I'm saying optimized code is not release code. because there's a slight difference in there that does matter. Okay, optimize code. So how do we effectively do this? So for Visual Studio, at least, we have a solution for this that we introduced earlier in this year called dynamic debugging. So in dynamic debugging, basically, whenever you have a breakpoint, it actually will take a de-optimized version of that function and swap it in so that when you're looking at the function, when it gets executed, I guess, and it breaks, you're now looking at the de-optimized version of just that function. Okay? It lets you see then all of the locals in that function. Okay? Now, we had a talk earlier. Eric Brummer, who's one of the lead devs on this, gave a good talk on how it works, how we did it underneath. I think he may have even showed how to do it in like a VCX proj, but you need to know how to do this for an Unreal Engine project and also for a CMake project. Okay, that's what I'm going to show you. So let's stop this and then go back to here. The easiest way, there's a couple different ways you can enable this for Unreal Engine projects. One is you can actually edit your target, like your build scripts, and like programmatically set, hey, I'm turning this on. What I found, to me, the easier way to do it, there is a like local file that gets generated that, I guess you could check it into source control under saved, Unreal Build Tool, build configuration.xml. Okay, so by default, this will be like an empty file. Okay, it won't have any of this contents right here. Let me make it bigger. Okay, so the things you need to do to enable dynamic debugging in your Unreal Engine project, you need to do this Windows platform, be dynamic debugging true, and then you actually need to turn off some features of the Unreal Build Accelerator for this to work correctly. Okay, so you'll set those to false. If you do this and then you redo your build, now all of your Unreal Engine project that got built there will have dynamic debugging enabled. Okay, so if you have code that, C++ code that was written there, you'll then get those de-optimized frames whenever you hit them with the debugger. Okay, but what about CMake? Okay, so let me go back over, and I'm going to go back to my library project. Okay, I've already done this. I actually pushed the binaries that have this enabled over to the repository. I'm going to turn them on in just a second in the Unreal Engine project. So how I would do this is I'm using CMake presets. So I would add a new preset for configuration, build, and test if you have a test. I just call it release DD. I build it on top of the rel with deb info underlying CMake build type. And then this is my own invention here for my project. I have a CMake variable in my CMake list file called use dynamic debugging. It's either on or off. Okay. So then if we go to the CMake lists, the changes I have there, I declare that I have this use dynamic debugging thing. Yep. This is just to make life easier for the rest of the code. If it's on, then you need to pass some flags, particularly this dynamic deopt to the compiler is the important one. There are other flags you either have to turn on or off, that it's compatible, that it needs, or that it's incompatible with. Okay? There's documentation out there on what it actually needs. Then in addition to your compiler front end, you also need to pass this dynamic deopt to your archiver, the thing that's building your library, your librarian tool, whatever, link or lib or whatever it is. You need to pass /dynamic deopt to that. And you also need to pass /dynamic deopt to any of the linker commands. Like if you're building an executable and you want to, or if you're building a shared library, you need to pass it in there as well. Okay. Now what this is going to do is this is actually going to produce a alt.lib or an alt.exe or an alt whatever, right? That just gets generated by the compiler. You don't have to specify it, but you do have to know it's there, because if you're copying these things around, you have to know to copy that thing with it, because it has to live alongside their original binary. So you can see here in my install logic, I just say, hey, if I'm using this, don't forget, go copy this go import alt lib as well. Okay? So you can see what that looks like. Back over here, if I go back to go Unreal, third party, go lib. So if I look in release, I'll see go impl lib. But if I look in rel with debug info, you'll see the alt lib there as well. Okay. So how do I actually get this then hooked into my Unreal Engine project? Not that hard. All I got to do So I go back to that go impl build.cs. Okay, and then let's make that smaller again. Okay, so you see the path here that is going to be finding this. I'm just going to change that. Rel with deb info. Control save. Now, when I build this, now it's going to be using the version of my C++ logic library that has dynamic debugging enabled. So now when I go and debug through, I hit the place stone and I want to like step through, now I'll actually be able to like go in and step through and see all sorts of great stuff. Okay, let's see how long it takes to build. We got 4.5 minutes. I think we might make it. Okay, and of course, I actually set a breakpoint in this code previously that never got hit before because I was not running with dynamic debugging on. But now that I'm using the dynamic debugging version of this, it sees this breakpoint now. Okay, and if you look, I'm not good with the zoom stuff, but if you look in the call stack here, you'll see that there's this little de-optimized tag right there on that frame in the call stack. That's telling you that yes, dynamic debugging is providing you all the things that let debugging work like normal, right? Instead of being a vagrant and like scrounging around and looking through memory to figure out what things are, it's just right there in your debugger. Okay, I'm not going to continue on that path. We're gonna go ahead and go back and let it finish starting and stuff, but you get the idea, right? Okay, close that, back to this. Everybody can still see the screen, that's good. Okay, so we know how to debug games now. Use dynamic debugging if you're using MSVC. If you're not using MSVC, the other tools don't have it yet. So achievements unlocked, bug smasher, no bug safe, even in an optimized build. We don't have an excuse that it's hard to reproduce anymore. You can get to them. We're doing blueprints, we're doing C++, we're mixing it all up, we're doing all sorts of stuff. Multimodal trainee is that achievement. Okay. The end, ... Or is it? Aha, announcing some DLC. It's dangerous to go alone, a game developer tutorial, revenge of the storefronts, okay? My original idea on this talk is I wanted to get really into the weeds about like, okay, so you got a game. How do you get it to people, right? Because it's not trivial, right? There's a lot of stuff you have to do. Not enough time to cover all of it, but I'm going to give you the very top level, like these are where you need to go to find out how to get it in different kinds of stores, okay? But first, we got enemies that are special to the DLC. Every DLC comes with special enemies, right? So we've got Locke, the arcane jailer. Like doing support for multiple platforms is not trivial, right? And if you intend to do this, the sooner you start, the better. Otherwise, you're going to find yourself way in the hole later on, doing crunch, and you're going to hate your life. Okay, so if you think this might be something you want, start early. Okay. Different processors or different machines have different processors. They're going to want different code to run optimally. They use different tools. Some use Clang, some use MSVC. They're all over the place, right? And the way you package them up and give them to the stores, they're all different, right? They all want their own little way. They all have different quality metrics you have to go through, different tests you have to pass. So you want to get on top of this as soon as you can if you plan on doing it. And then the gatekeeper. These are actually the stores, right? Like, what do you have to do to convince somebody to get your game in their store? Sometimes you got to pay. Sometimes it's free, but sometimes you have to, meet certain requirements. And then the tools for publishing these things are all different too, right? Okay, but there's some help. They're actually pretty good. They want you to put your game in their store, right? So like, these are some links from Steam and Nintendo and PlayStation and Xbox of ways that you can then get your games as like an indie, as someone who's starting out, in their platforms. Okay, actually Nintendo and Steam, it seemed pretty easy to me. That creators program also seems pretty easy for Xbox. So yeah, check those out. If you actually get a game and you want it to get to people, check those links out. Okay, we're at the end. We finished the main game. We finished the DLC. We didn't really finish the DLC. You got a sneak peek of it though. And we got 35 seconds left. Obligatory talk slide, and we're done. Any questions? I got time for one question live if anybody wants to ask it.
I don't know.
Yeah, go ahead.
So
I really appreciated the talk because it's very genuine kind of like outlook in this process, but it also like really makes me not want to use any engine. It feels like you're spending a lot of time, dealing with the idiosyncrasies of the language of the engines, trying to figure out the build paths and all that stuff.
Yeah.
If you consider using something like a library like Raylib, SFML, SDL, where you write your code as it is and then you just draw using the library, I feel like for something like Go, it would be so much simpler. You know, to deal with that.
You're probably right on. I picked Unreal Engine because it was convenient. There's lots of actually the Unreal Engine documentation is actually really good, really thorough. So yeah, check that out too. But yeah, point well taken. There's lots of different ways you can build this type of game. Okay, I think we're done. Thanks everybody. You can catch me outside if you want to talk some more.